In this video, I'm going to go through the first three questions of your quick check over heat and matter. And these first three questions involve the formula Q equals mc delta T. So feel free to flip to the specific question that you have questions on. Now, as a reminder, Q equals mc delta T could also be called Q equals mc T final minus T initial. Okay, those are the same thing. So this first question says, what is the heat change? So we're solving for heat. That's what we're solving for. When 432 grams of water cools from 71 degrees Celsius to 18 degrees Celsius, the specific heat of water is on the back of your laminated periodic table, and that is 4.184 joules divided by grams degrees Celsius. Okay, we are given mass, and we are given some temperatures. Okay, so first thing I'm going to do is I'm going to write my formula Q equals mc TF minus TI. We are solving for Q, so we'll leave that blank. Our mass needs to be in grams, and it already is, so that's 432 grams. The specific heat of our sample is just water, 4.184 joules divided by grams degrees Celsius. And then to figure out the initial or the final temperature, I need to use some context clues. So one context clue that's really important is it says that our water cools, and so when I solve for Q, it should be negative because it's releasing heat. That's what happens when the substance cools. And so it must have 18.0 degrees Celsius as its final temperature and 71.0 degrees Celsius as its initial temperature. So all I'm going to do and plug into my calculator 432 in parentheses, 4.184 in parentheses, and then 18 minus 71 in parentheses. And when I do that, let's see what I get. Okay, and I'm not going to worry about significant figures here. I got 95,796.864, but it's all negative, so negative 95,797 joules. We'll just cut it off at the ones place, is our answer. Okay, question 2 says, what is the specific heat? So that's what we're solving for. That variable is C. Of aluminum if the temperature of a 28.4 gram sample is increased from 2.0 degrees Celsius to 10.1 degrees Celsius when 207 joules of heat is added. So our formula is Q equals mc TF minus TI. And we can plug in what we know. We have a Q here. We have some temperatures. We'll figure out which one's initial and final later. And then we have a mass. Okay, so our Q is 207 joules. Our mass is 28.4 grams. Our specific heat is what we're solving for. And we are increasing the temperature of our sample, which means 10.1 degrees Celsius is going to be our final. We started that at 2.0 degrees Celsius. And I just need to solve for C. So let me walk through the math of this. First thing I'm going to do is I'm going to ignore units. I know that specific heat is in joules per gram degrees Celsius, so whatever number I get here, it should be in those units if I do my math correctly. So we have 207 equals 28.4 times C, or call that X, and then 10.1 minus 2, that's going to be 8.1. I'm going to multiply these two numbers, 28.4 times 8.1, and I get 230.04. Then I'm going to change that variable C to X. That equals 207. To isolate X, I'll divide each side by 230.04. And X is going to be 207 divided by 230.04. And this is aluminum. I actually know the specific heat of aluminum, and it rounds to be 0.9 joules per gram degree Celsius. Okay, the last one we're going to do here is number 3. And number 3 says a sample of 25 milliliters of water at 24.5 degrees Celsius was placed on a hot plate and it absorbed 250 joules. That's a Q. And then that's a temperature. We need to solve for the final temperature of the water. So our formula is Q equals MC T final minus T initial. I'm going to plug in what I know. 250.0 joules equals our mass. Now, because I'm solving for final temperature, my mass must be given somehow. And here's what's a little bit tricky on this one. 25 milliliters of water, if you remember, the density of H2O is 1 gram per milliliter. So I could just convert really quickly. If I have 25.00 milliliters, for every 1 milliliter of water, that's 1 gram of water, and so that really is 25.00 grams. That's a little bit tricky. The specific heat of water is one that's on the back of your laminated periodic table. We're solving for the final temperature, TF, and then the initial temperature is 24.50 degrees Celsius. We're placing our water on a hot plate, so I expect TF to be warmer than what it started at. I'm going to multiply these two numbers, so 25 times 4.184, and I get 104.6 times, and I'm going to change TF to x minus 24.50, that equals 250. Divide each side by 104.6. 250 divided by 104.6, that's going to be 2.39. That equals x minus 24.5. Add 24.5 to each side. 2.39 plus 24.5. X is going to be 26.84 degrees Celsius.